Okay, continuing the review, page 3. We have another expression of an equality with a radical sign. So remember, our restrictions are what's under the radical, 3x plus 2, cannot be negative. So 3x plus 2 greater than or equal to 0. That means 3x greater than or equal to negative 2, x greater than or equal to negative 2/3. Okay, so that is my domain restriction. Okay, now to solve for x, isolate the square root and square both sides. So in order to do that, I will have 3x plus 2, the square root of that equals 3x, and I need to square both sides of that equation. So when I square both sides of the equation, on the left, I get 3x plus 2. On the right, when I square 3x, I get 9x squared. Now, to solve this, I need to set it equal to 0. So if I move the 3x and the 2 to the right, I'm going to have 0 is equal to 9x squared minus 3x minus 2. You can go ahead if you're more comfortable writing it 9x squared minus 3x minus 2 equals 0. In order to solve this, I need two numbers that multiply to give me negative 18 and add to give me a negative 3. So that's going to be a 6 and a 3, and with a negative in front of the 6. Multiply those numbers, you get negative 18. Add those numbers, you get negative 3. So I'm going to rewrite this as 9x squared minus 6x plus 3x minus 2 equals 0. Factor by grouping. So I can factor out a 3x, and then I'm left with 3x minus 2 plus 3x minus 2 equals 0. Therefore, I'll come up here. My factorization is 3x plus 1, 3x minus 2 equals 0. Set them equal to 0. So if 3x plus 1 equals 0, then 3x equals negative 1, x equals negative 1/3. And if 3x minus 2 equals 0, then 3x equals 2, x equals 2/3. Anytime you square both sides of an equation, you're going to need to check both of those answers. So let's check x equals 2/3. So I'm going to plug that into the original equation. So 3, and all I'm doing is plugging in 2/3 plus 2. Does the square root of that equal 3 times 2/3? So I just plug 2/3 into the original equation. So when I do that, I get, this is 2 plus 2, that's the square root of 4, equal 2, or 2 equals 2. That checks out. Now I need to check x equals negative 1/3. So I'll plug that back into the original equation. So 3 times negative 1/3 plus 2 equals 3 times negative 1/3. So this, inside the parentheses, the 3 and the 3 cancel. This is 2 minus 1, that's 1. So the square root of 1 equal negative 1, 1 equals negative 1. This does not work. So this is not a solution. So that's not a solution. And so in this case, my only solution is x equal, right over here, 2/3. So that is my only solution to that equation. So again, checking for extraneous roots anytime you square both sides of an equation. Now back to the equalities, I think people found those a little bit more straightforward. Strategy here, break this into two problems. First problem is x plus 7 greater than 14. Second problem, x plus 7 is less than negative 14. And solve each of these. So if I subtract 7 from both sides, I get x is greater than 7. Here, if I subtract 7 from both sides, I get x is less than negative 21. You don't have to draw a number line, but it's usually very helpful. Draw the smallest number here, largest number. X less than negative 21, that's this solution. X greater than 7, that's this solution. Now what I'm after is your answer in interval notation. The first interval is negative infinity to negative 21. That second interval is 7 to infinity. So that's my final answer for the solution. Very similarly, look at the next problem. Same concept. Break it into two problems. First problem is x minus 2 less than or equal to 1. Second problem, x minus 2 greater than or equal to negative 1. So if I add 2 to both sides, x is less than or equal to 3. Add 2 to both sides, x is greater than or equal to 1. So on a number line, that is 1 and 3. And like I said, on the test, I probably would not make you do the number line. It's just a good way to do your final solution in interval notation. Smallest number to the left is the 1. So greater than or equal to 1, less than or equal to 3. That's this. So that interval is negative 1 to 3 with square brackets. Okay, that's page 3, I believe.